Hello again. My name is Sebastian. I'm the CTO at Stateful, and we make RunMe. I wanted to re-record a portion of my talk that unfortunately I couldn't fully demonstrate due to some internet issues when I was giving the talk at Rejects EU ahead of like KubeCon in Paris. And the portion of the talk that was called um, an IDE for operators should be integral to your docs is essentially around how open source notebooks, a notebook kernel that is native to Dash and cloud native, is based on open source standards, can essentially fulfill this promise of creating an IDE for operators that is integral to your docs. So since the internet was out, I couldn't really show all the functionality and how that is related to open standards. So this is what we're going to be doing now. Cool. So we'll start over here. This is an example repo. I'm going to show the URL and the QR code to it at the end of the talk or at the end of the demo. But the quickest way to get started is just to use a RunMe badge inside of a Markdown document. RunMe is native to Markdown, so any Markdown document it can conceivably open inside of a notebook, and that's what we're going to do here. Click on it. It brings me right into VS Code, which is the runtime or the platform that RunMe is built on top of. The relationship is a lot like Chrome is to Chromium or Brave is to Chromium. We built on the on the VS Code platform so that the notebook UI is portable and you can run it here locally, self-contained on your computer, or attached to a SSH host or a container. And there are plenty of other runtimes like Gitpod, Codespaces, yada yada that support this notebook UI based on the fact that it's built on top of VS Code and the VS Code platform. So yeah, this is a vanilla the Markdown document. There's nothing special about it. Essentially what we have done is we built this notebook kernel. It parses every code cell that's contained in the Markdown into a executable block, and you can see how it ran here. What we can also do is we can create a carbon copy of the output. So what that means is like a separate file will be generated with a session ID that contains not just the input, but also the outputs. By default, RunMe will not write outputs back into the source file because that wouldn't really make sense for generic notebooks. So now to the looking a little bit under the hood how this all works. We're going to skip the steps how to attach to a Kubernetes cluster. I've already done that, but it's inside of the repo if you want to try it for yourself. We're going to hop on over to the first step, and what that will help us do is understand how open standards are being used to provide a documentation experience that's like native to operators. And one thing that is great about RunMe is that it can't just execute commands and code, but it can also inline your cloud resources. So for example, here's a list of clusters that I have provisioned in my GCP in the project RunMe CI, and I can just handy dandy inline that into my documentation. And what that will do is instead of making me log into the console, I can just bring any relevant cloud resource into my documentation, right? Which has a nice side effect that it's always up to date, because when I run the documentation, that is the snapshot, that you're getting. Not the last time somebody ran it, when that was like a month ago, for example, right? And I can do stuff like, just kind of traverse into the resources and, examine them, look at the metadata, that sort of stuff. Cool. And the way this works, again, just like the terminal, is it is just a vanilla web component, right? Part of this notebook framework and these APIs that the VS Code platform provides is that you can have custom renderers that are just built using web components. So that's one of the standards that we're covering here. Cool. Moving on to the next part of the demo. So RunMe CI is our project. We have a cluster that lives inside of Europe Central too. When I was in Paris, that made sense. Now I'm in the US. I think the latency will probably be okay, so we'll stick with that. And the cluster name is Rejects. So essentially what this does is it just pulls in the kube context, right? Configures my local kubecon to be attached to that cluster, which is also really nice because I didn't really have to worry about how to get there. I just basically followed the steps in the documentation. Again, this terminal in here is actually just a web component, which we have already implemented to render it for you inside of RunMe, right? And then what that lets me do is just, the vanilla old, we'll tail some namespace as pods, and then, we apply a manifest just to showcase how this works. And off we go. It just creates the resources, right? Nothing special here, but again, everything is inside of the documentation. No need to go anywhere else, right? Cool. Next part, going back to this concept of bringing in resources. Here's just a different take at it, where instead of like the clusters, we'll see all the nodes that are attached to clusters, because we're just looking at all the compute instances inside of GCP for a particular project. And, of course, these vendors can be available. We have some for EC2, we're working on Azure. And this is all open source, so we'd love to have more for all the clouds that are out there, including like ones that are not public, right? Like OpenStack. What's really cool about those components is these web components is that you can actually, like have follow-up actions. So if I wanted to, for whatever reason, debug something on that particular node, maybe look at the image cache or something of that sort, I can just jump right into an SSH session because like the way they're connected using that web component-ish aspect of it allows us to almost build an application-like experience on top of it. But notice how I didn't leave the documentation, which is really important. Again, we can have a session record of that. For the web components, it saves the underlying JSON representation of the API call. And for the SSH session, I literally get the SSH session. So as you can see here, if I do ls root directory and I save it, I get the same thing over here. So this is a carbon copy of your session containing inputs and outputs, whereas the source document will only ever really include the inputs because we want to make it generic and shareable, right? So just to kind of drive the point home, we can also do this with GitHub resources, right? For example, I could release a new version of the extension right here by running the workflow. I'm just going to do that now because I'm shipping a pre-release, which is safe. And as you can see, it just triggers a workflow. I can hop on over, look at it in GitHub if I wanted to, but I don't really have to leave my documentation, which I really like. Cool. Next one, really hot, standard and something we're really excited about is OpenTelemetry, right? So, if you wanted to keep a record of what went on in your notebook, and you have an existing OpenTelemetry collector, right? Whether it's Jaeger or any of the commercial providers, you can just use that. And the way this works is I have a Jaeger running here, so I can show you. It essentially just writes the traces, right? Anytime I run a cell, it will just, essentially break it down into its constituent parts. This is hierarchical, it has a notebook, it has a cell, and I run multiple cells. Jaeger obviously puts it in a nice timeline view, which is really nice to be able to debug and look at metadata, right? So this is a very honest way of keeping a record because as a user, I do know that if I hit the play button, if this feature is enabled, and conceivably you could have a big green bar up here that tells you that the traces are being sent somewhere. So this is not a sneaky way of tapping into your terminal or something of that sort. Cool. And again, this is OpenTelemetry, which is really handy, right? Because it's an open standard. Again, nothing proprietary about this. The last thing to quickly touch on is the feature that we call ops containers here, but this is leaned on the dev container spec. So the idea here really is instead of running this against my local host system, which is Mac OS Darwin on my laptop, I can open this repo inside of a container, right? And I have Docker currently running here, Docker for Mac. And what's great about this is it launches the repo inside of a dev container. And the dev container here, or how I like to call it, ops container, could be pre-built, right? It could leverage your existing tooling so that you don't have to reinvent the wheel, right? So you can use your whole supply chain of Docker containers and image builds that you have already figured out, including scanning. And now when I run this, you'll see that I'm actually running against Linux, right? Which is the virtualized environment that Docker for Mac makes available for me. And this is really handy if you don't want people to be having to worry about installing system and dependencies and package managers and all. You can all bake it into a base image and just use that for all your runbooks, all your cloud native documentation, right? And it's almost like a pipeline, but it gives you this interactive flexibility. And yeah, so this is kind of taking us to the end of the part of the presentation that unfortunately didn't work. But if you have any questions or you want to hear more about this, follow the link and feel free to email me. Also check out the OWL. It's really interesting. It's a type system for the environment. You can find more in the actual rejects video. Thank you so much.